All right, hi everyone. I'm here with Johnny, assistant professor at Madrid. First off, we just want to ask, what makes Puzzle X so unique, and what are you enjoying the most so far?
Well, the uniqueness of Puzzle X is the people. I've never seen such a mixture of backgrounds, and I'm having very good time talking to industry people as an academic. It doesn't happen as often, and I'm glad that there's also representation of politicians, and it's lovely. People who make the policies, and people who should know about the science behind it.
Great. So, what do you
Yeah.
think the biggest difference between like this conference and a academic conference where you would normally do like paper research on electrochemical society or things of that nature?
Well, first of all, academic conferences are quieter. Then, well, depending on the conferences I've been, I think people are more focused on their own topic, and they get technical immediately, and you tend to see clusters of people who do this topic, people who do this topic. But here, people mix more, and yeah, so that's the main difference, and yeah, of course, the kind of discussions you have are more like everybody asks you what's your latest result, and here they ask you what do you do for a living, and that's nice. That's really nice.
Awesome. And so, talking about what you do for a living, so
Oh, yeah.
your focus is on quantum computing. So we've heard a lot about quantum computing so far and the benefits of it. I think you have a very interesting take about how quantum computing can affect our economy. So could you elaborate on that idea?
Yeah, so for a living, I teach basic computer science and advanced computer science. But well, it's still for a living because research is part of my job. But it's a hobby for me. I study game theory, which is it says games, but the games are situations of conflict. Okay, so where there are different players, each with an objective. Imagine when you take your card and it says, oh, you need to do this, right? Each player has their objectives, and we actually study theoretically and rigorously how behaviors change in the presence of quantum resources.
Wow.
Because when you communicate normally, you do it in a certain way. When you communicate with quantum information, different rules apply, and so you read different things, you know different things, and we study this knowledge of how the knowledge of other people's strategies affects the overall equilibrium, for example.
Yeah, so I think I was going to say that when I took game theory, I actually took it in college. A lot of applications were in economy and like what a normal consumer would do in using game theory to analyze those decisions. So going on to your next topic, how are you using this information that we're now gaining to take insights into the economy or in other areas of our life?
Okay, we are doing two main things. One is provide a framework for studying specific games. Okay, so we're designing the framework that says, you can put, for example, a mediator that uses quantum information to communicate with two parties, and you need to model it this way. The equilibrium class you get is this. So it's really, we are laying down an operating system for studying this kind of problem. And then we have some toy examples, but we are limiting it like demo applications for now.
Okay.
And the other thing is that this is the thing I presented here. Is we are actually rebuilding completely from the basics the whole basic theorems of economic theory. Like, for example, my latest result is a quantum version of the Aumann's theorem on agreeing to disagree, and which is one of the basic theorems that are used in game theory overall. So we made a quantum version considering things like that. So we are setting up the stage to be quantum ready, if you allow to say this buzzword, even for economic theory to be studied.
Awesome. And so taking this framework, let's say within the next 10 years you can finish it, what does 20 years from now look like? What applications do you think will be the most important to how it changes how we interact with the world?
Yes, okay, that's a very good question, because I imagine in 20 years from now, quantum communications will be a total full reality, and there will be things like cryptography, but even things like, for example, high frequency trading and stuff like that, made with quantum resources to collaborate and coordinate better. And thanks to the work we are doing, we know how to study these situations, and people will have learned what to expect from the behaviors of each other, even with quantum resources. So we will know how to use the hardware well.
Amazing. Great. Then I guess that's a lot to look forward to.
Sorry.
It's okay. So I guess for the final part, thank you so much for talking to us. The final thing we'll have you do is look right into the camera and say, my piece of the puzzle is quantum computing, or a two-word phrase to describe what you're working on.
Okay, wait a second. Let me think one second.
Yeah, no problem. Take your time.
Yeah. So my piece of the puzzle is basic building blocks for the future theories.